Learn well when we're doing formulas. Are they easy to remember?
No.
I know that we throw lots of them at you. Length times width times height. Length times width. The 1/2 the base times the height. Side plus side plus side. I teach it and I get confused. So what's a good way to understand and be able to internalize it, Nick?
Hands-on activities.
Hands-on works really well, yes.
Actually, like, look at it and understand.
Look at it and understand it. When you're building a model or a car or something, is it easier to understand it if you're actually touching it and manipulating it?
easier.
How many of you on Christmas morning see Mom and Dad trying to put something together? Put part A to part B, use screw B. That's not how I do it.
Yeah.
What's the easiest way to do it?
Look at it.
Look at the pictures, look at the shape, touch it, see where it fits, and sometimes we end up with some pieces left over sometimes. But that's the easy way to do it. Where do you think these formulas come from that we're going to talk about today? They've been around for a while. How long do you think they've been around? What's it?
300.
You say 300?
500?
500?
Million?
A million years?
1,000?
Well, let's talk about that a little bit. Let's see how long formulas have been around. Okay, hold on, let me move this. That's the problem. There we go. There it is. I wonder where my arrows went. Okay, we already talked about why students have difficulty with area and volume calculations. You know formulas, but where did they come from? Base times height divided by 2. You already know that. We've studied it. We've talked about it. Formulas, including the formula for the area of a triangle, have their origins in the geometry of the ancient Greeks. It was codified or written in Euclid's Elements. This is a book he wrote about math. What's his name? Euclid. And he was around in 300 BC.
Okay, that's real low. That's real low.
That's like 300 years before Jesus was around. That's a long time. So that was a long, long time ago. And Euclid sat around, he was a thinker. He just sat around thinking about things. I wonder how we could figure out the area of a triangle. Why do you think it might be important to somebody in the ancient times? What are some examples in ancient times you might be able to think of that involve triangles? What's one?
Them building the pyramids.
The pyramids. When you see the pyramids now, they look all rocky, but when the pyramids were first being built, they used to cover them with lime so that they were smooth. And in order to cover them, you have to know what?
The area.
Yes? The area, how much you're going to need to do that. So formulas like Euclid came up with would be very, very useful in determining how much lime they need to actually cover the pyramids because that happens to be the shape of a triangle. That's one example. Yes?
Like doing the Colosseum.
Building things, building colosseums. Lots of geometric shapes and formulas were used. The Romans and the Greeks were fantastic builders, so they learned how to build things and how to make these formulas. Euclid was a thinker. We've been talking about a thinker lately in science. The guy with the apple, what was his name? He was a thinker.
Well, Isaac Newton?
That's right. What did he think about when he was thinking?
Why does stuff fall down, not up?
That's right. Why do apples fall down on top of me, not up? This is the same kind of guy. He was a thinker. He wanted to think about how this happened, and this happened all the way back in 300 BC. That's a long, long time ago. It took Euclid many years to develop the formulas that we use today, but I'll bet we can prove his same formula he came up with in a very short period of time. In a very short period of time. Why is it we can do this now in such a short period of time, and it took this guy thinking years to come up with his formula? Why do you think? Jasmine Green.
Because we have better technology.
Better technology. What's another reason?
We're really smart and we've learned over the past of the years.
We've learned and learned and learned. You take the learning we have now, and it's like a pyramid because we take the old learning and what do we do on top? Stack new learning. And we have a mountain of new learning since Euclid was around. We teach the principles that took him years to think up. We start teaching them now early algebra in 2nd and 3rd and 4th grades. By the time it gets to you, you're working on the same formulas that he designed. So let's see if we can figure out how Euclid came up with his formula for figuring out the area of a triangle. And it's not very difficult, but it took him a long time to think about it. At each group, I've paired you up, and with your partner, you have a set of triangles. Everybody hold your pair of triangles up. Hold them up. You have 2 of them. Now in just a minute, I'm going to let you look at these triangles. And I want you to give me some characteristics. What's a characteristic? What's a characteristic? What's a characteristic? Yes, Jeff.
Property.
It's property. What's another word for characteristic? Yes.
Like how it feels, what it looks
How
like.
it feels, what it
color.
looks like. What's another word we can use for characteristic or property?
Attributes.
Its attributes, its size, its shape, all those things. So take just a minute and look at them, play with them, and when you have an aha moment, stick your hand up so I can see what kind of ahas you have. Oh, somebody's already got one. Think about it in just a minute. Let's be thinking for just a minute. Come up with an aha moment. Aha. What's your aha?
Make a bigger triangle.
Okay, you can take two triangles and make a bigger triangle. Does that work for all of them?
Some, yeah.
A lot of them or all of them? Aha. What was your aha? Put together to make a rectangle. Is that true in all of them? Let's have a look at this one. Let's have a look at this one. I take my two triangles, eyes up here. If I put them together, what do they make? Do they all make rectangles? Have a look, guys. Some of them make what?
Squares.
Some squares, parallelograms, quadrilaterals. They all have four sides,
Yeah.
and they're all parallelograms. Then we can figure out the area of a square, quadrilateral, or parallelogram. We started learning that in 3rd grade, and that's length times width, right? Just as simple as it. What's the area of this thing up here? Tell me, what is it? 40?
100.
100. Thank you. 10 times 10, which is 100. Someone was giving me perimeter. They gave me 40. That's 10 plus 10 plus 10 plus 10, which would be 40. But I wanted the area, and it's 10 times 10. So this is 100. That's pretty simple stuff, isn't it? We've been doing that for a long time. Now, look at your triangles for a moment. Are they the same size and the same shape?
Yeah.
What does that mean? What's that word? Congruent means what? Euclid learned a long time ago that any one triangle has a matching pair somewhere in the world. And you can draw this in with your eye. If you can see that, draw that in with your eye. Now, how did that help him figure this out? Well, look at this square here. Pretend that we take this square and we cut it in half. We know the area of the whole square. You just told me. What is it? 100. Well, if I cut it in half, what's the area then of this half?
50.
And this half has to be 50. All right, so let me make this half go away. And what did I end up with in the end? What shape is that?
A triangle.
A triangle.
Triangle.
It's a right triangle. And what's the area of this triangle?
50.
50. So he figured out, oh, wait a minute, every single triangle, you can make an imaginary box. So if I can figure out what the length and width is, I can get the area of the whole box and then cut it in half, and that gives me the area of a triangle. That's how he figured out that 1/2 of the base times the what? Height equals area. Makes area. So we've been doing it how in class? Base times height divided by 2 equals area squared. So is that the same thing? Are those both the same thing?
Yes.
More than one way to skin a cat. So here's what I want you to do with your triangles. I want you to put them together so that they form a rectangle. And I want you to measure the length and the width and figure out the area of the whole rectangle. And then I want you to cut that in half and tell me what the area is for your particular triangle. Everybody understand the assignment?
Yes, sir.
Do that real quick. You've got rulers at your stations. Check them out. Yours makes the rhombus. We know how to find the area of the rhombus. It's base times height. So just measure your height.
Centimeters? Measure the height.
Let's do centimeters today. Let's do centimeters today. Okay? Let's see, if we turn that around the other way, that probably would make an easier match. Still, it's going to be a rhombus no matter what we do with that one, isn't it? Okay, so base times height. Are all these triangles the same?
No.
No, Euclid's principles apply to all triangles. Base times height divided by 2, or 1/2 of the base times the height.